Hey there, welcome to Module 2.4. So you should have a worksheet in front of you. The worksheet is kind of comprised of two different worksheets, so just bear with me. But anyways, on one side it should have this problem, and then on the other side should be one that's talking about logarithms and changing them into exponential. So anyways, on the side that has that first one, I'm going to show you guys the answers for just these first couple, and then I want you to complete this whole side. So when it says to expand each logarithm, that means that you're taking a single logarithm and writing it into multiple. And for this case right here, since we have one operation, that means we're going to end up having two logarithms in the end. Okay, so when you see this one will expand, since it's division, into subtraction. Now I would say keep these in parentheses just so that you're safe and you are organized. So over here, since this one has multiplication, we know that multiplication is going to turn into addition. So again, I would just, you don't have to have these parentheses, but that just kind of keeps you safe. Okay, now down here, this one says condense. So for each of these, we're going to, almost like combining like terms, we're going to take two logarithms and write it as a single logarithm. So we're familiar with the subtraction and the connection with division. So that one is going to be written like this. Now I would, again, recommend that you put these in parentheses. They don't have to look as weird as what I wrote, but something like that. Now if I have a plus right here, what does that mean that we're doing? Good, so that means we're going to be multiplying. So you could write it as 12 times 5, but why don't we go ahead and simplify it and make it 60? Okay? All right, so why don't you guys try? I'll give you a couple minutes. You pause the video, and then we'll move on to the next slide. Okay, this was some homework from last night, so you guys can check that on your own. Pause the video if you need. Going right along. Okay, so on the back side of that worksheet that I gave you, this is just kind of helping you if you guys need your kind of like a refresher when it comes to logarithms. So you can check that at your own pace. But let's go ahead and get started. So 2.4, we are going to be looking at properties of logarithms again, and then writing logs in terms of others. So this is kind of complicated at first, but it's really not that bad. So let's get started. So don't forget our properties. This is on the back side of your stamp sheet. Make sure that you guys understand them completely, especially by the time it comes to the test. So let's keep going. So these guys are having a conversation. You guys could read this on your own. And basically what's going on here is this guy's like, all right, so I know that this equals that. And the guy's like, yeah, of course it does, all right? And he's like, everybody knows that log base 2 equals 1, but what about base 2 3? What the heck does that equal? And so they keep on going. He's like, oh yeah, I saw this somewhere. You know, that equals 1.585. You know, and it's like, yeah, sure, who's this guy? Anyways, so then he's like, all right, so maybe what we can do is we can replace that. We can replace this as being 1 and replace this whole thing, this guy right here, okay? This as being this. Okay, so if we know that this equals 1, we can kind of simplify a logarithm that we're not familiar with. Because the problem is this. When it comes to base 2, we're needing this to be powers of 2. And when we have a 6, we don't know. Okay, so what these people did is they said, okay, well, log 6 is the same as 2 times 3. Okay, and since we know what this is, log 2 like this, we know that this equals 1. If only we knew what log base 2 3 equals, then we could say that this is 1 plus whatever this value is. Okay, now I'm not expecting you guys to memorize something like this, so don't worry about it, but just trust me that this will end up helping us in a second. So I'm going to skip ahead here to the next slide. So using the rules of logarithms, we're going to kind of focus in on these things that are on the top right here. So if you're not already there, I want you guys to turn to page 27 in your packet. And it gives us a couple values. It says log base 2 3 is 1.585. Then it gives us log 5, and then it gives us log 7. And so we're going to use these properties to try to figure out what this one would look like. Now I see that I have base 2, so I know that this one's not going to turn out real nice. It's going to be kind of ugly. However, when it comes to 9, is there any way that I could write it in terms of a 7, a 5, or a 3? So think for a second. Yeah, of course. We could write it as 3 times 3. So if I write it as 3 times 3, and I know that log 3 is 1.58, it would look something like this. Okay? I can write it as 3 times 3, so two separate logarithms, and now we know what this equals, so I can say that that's 1.585 plus 1.585, and then we get our answer. So that's what it means when it says writing logs in terms of others. Okay? Writing logs in terms of other logs. So how can we write 10? Why don't you guys try this? Good. So we could say that that's log 2 times 5. And then we have the value here. That's 2.322. And then we should know what this value is. We can evaluate that logarithm as being 1. So we get 2.322 plus 1. All right, at any moment, don't forget that you guys can pause this or just stop the video. So don't forget about that. But I want to ask you a test question. So here's a dude. He says, "Oh, I totally got it," and so he does this this procedure. So my question is, if this was on the test, is he correct? And then if he's not correct, where did he make his mistake? So the mistake here is that in order for us to write it as the sum of two logarithms, this right here needs to be multiplication. So that's where he made his mistake. Okay, moving right along. So I want you guys to try these. Okay, you can pause the video, give them a shot, try to write it in terms of others. So think 12, how can I write that in terms of 3, 5, or 7, or maybe anything that has a power of 2 as its base? Okay, so for this one I said 3 times 4, and log base 2, 4, that could be simplified to being 2, and I know what log 2 base 2, 3 is. And now the next one, 7 and 3, we could obviously write that as log 7 minus log 3, and we have those values here that were given. So we can simplify that. 30, this one's kind of complicated. So 30 is the product of 5 times 6, and 6 is 2 times 3. So notice what I did. 5 times 3 times 2, and then since it's divided by 7, we've got the 7 right here. Now log 5, we have that value, which is the 2.322. Log 3, we have the value, which is 1.585. Log 2 we know is 1, and then log 7 we have as 2.807. Okay, and then we just add those up using our calculator, and then we're good. Okay. Now before you guys like kind of look at this and be like, wait a minute, hold on a second, Mr. Wilson. Can't I just use change base form and be like, hey, look, log base 2, 12 is exactly the same as log 12 divided by log 2. And you're right, you can do this and you'll get the same value for the most part, okay? But I'm telling you that on the test that I'm not going to make it that simple where you could just use your calculator. Because I'm gonna be giving you guys these decimals, and I'm gonna be rounding. Like say this one right here, I'm gonna round that to a 6. So the answers that you're gonna get won't be exactly the same. I'm forcing you guys to use this concept for these questions. Now everything else on the test, I don't care. You guys could use change base form all day, any day. Okay, but for these particular problems, you're gonna need to know this procedure. So don't just discount what I'm teaching here. Okay, next. Now this one, the 486 is just huge, so you're just going to have to divide. And I just said that it's 3 to the 5th power, and I put the 5 in the front. And then we have log base 2. Okay. So let's keep going here, moving right along. So here, what I want you guys to do for this one is kind of like what we did on the previous example where it says sometimes true, or never true, or it is true. Okay. So it says if the answer is sometimes true, then describe the conditions that must make it to be true, okay, that need to be happening in order for it to be true. So here, is this a true statement? Will this equal that? Yep, that's true. Good job, because of the logarithm property. Okay, now this one right here, we have a 3. We got x squared. Is this one true? Okay, I said that this one is sometimes true because it's not that it's not true, It's that this could be true in the event that we're dealing with, like, let's say we have log 3, so then it says divided by x, okay, and then we have to divide the next one by x, so that means that we're saying divided by x. So if I'm dividing by x, that's the same as multiplying by the reciprocal, so we could say that that's the x squared. Okay, however, this is a pretty tricky one because I think that you would want to put those brackets there, so that's why I'd put sometimes true, so I'm going to put a star next to that one. Okay, next. Is this true? This is actually a common mistake, okay, when I see it when I'm grading your guys' tests. When you're condensing into a single logarithm, there shouldn't be 2 logarithms here. So yeah, this is a mistake. It should be 1 logarithm and then the division not underneath the log. So that one's false. And then what about this guy? Is that true? Yep, because of the property. All right, let's keep going. Let's go here. Does this equal that? False. What about this? Does this equal that? True. Does this equal this? Absolutely not. Okay. All right, so here's your classwork. Go ahead and get started on that. Check your answers on the PowerPoint, and then you guys could go from there. So good luck, and we will see you guys next time. Me, myself, and I. That's what I meant. Okay, bye-bye.